Today, let us learn about the laws of exponents. Remember that the exponent is a number written at the upper right of a variable or of another number, which tells the number of times the variable or another number is used as a factor. So that if I have the expression 3 exponent 4, or you can also read it as 3 to the 4th power or 3 raised to 4, 3 is called the base and 4 is the exponent. So that we can rewrite it in this manner. We use 3 4 times as a factor because the exponent of 3 is 4. Or to simplify it further, we will have 81. If I have x to the 7th power, we are going to use x 7 times as a factor because the exponent of x is 7. So to define it mathematically, if I have a raised to x, we are going to use a x times as a factor because the exponent of a is x. Now, where do we use exponents? Exponents are used to simplify numerical and even algebraic expressions, so that if I have this numerical expression which is a bit long, we can just simplify it using exponents as 2 exponent 6 or 2 to the 6th power. Why did I use exponent 6? Because we use 2 6 times as a factor. In the same manner, if I have this algebraic expression, we can simplify it as 3x to the 6th power y to the 4th power because there are 6 x's and there are also 4 y's. Now let us simplify x squared times x cubed. To do that, we are going to expand the two expressions so that you will see 2x's for the first group because the exponent of x is 2, and you will see 3x's for the second group because the exponent of x is 3. But looking at our expression now, we arrive at a total of 5x's, therefore we can simplify it as x to the 5th power. So the simplest form of x squared times x cubed, or the product of x squared times x cubed, is x to the 5th power. If I have y to the 4th power times y squared times y cubed, expanding them depending on their exponents, we will see a total of 9y, so the simplest form is y to the 9th power. But there is another way of simplifying these expressions without expanding their exponential numbers. We simply add the exponents so that if I have x squared times x cubed, you add 2 and 3 and the result is 5, so the simplest form is x to the 5th power. For the second example, add the exponents 4, 2, and 3, that is equal to 9, so the resulting expression is y raised to 9. So if I have a raised to x times a raised to y, to simplify it without expanding, you will have a raised to x plus y. This law of exponent is called the product of powers. Product of powers states that if you are to multiply two powers having the same bases, copy the common base and add the exponents. Now let's also simplify the square of c cubed, or the quantity c cubed squared. To do that, we will expand the whole expression so that we will have c cubed times c cubed because the whole expression has exponent 2. Applying product of powers, we will arrive at c to the 6th power. If I have the cube of x to the 4th power, or the quantity x raised to 4 cubed, by expanding it, we will have this expression, and then applying product of powers, we will add the exponents, so the result is x to the 12th power. But this time, I am again to introduce to you another method of simplifying these expressions without expanding. And how do we do it? We simply multiply the exponents. So that for the first example, we will multiply the exponents 3 and 2. 3 times 2 equals 6, so the resulting expression is c to the 6th power. That is now the simplest form of the first example. For the second example, we will multiply the exponents 4 and 3. 4 times 3 is 12, so the resulting expression is x to the 12th power. So that if I have the quantity a raised to x raised to y, to simplify it, we will simply copy the base and then multiply the exponents. And for your information, this is another law of exponent which is called power of a power. Power of a power states that if you are to raise a power to another power, just copy the base and then multiply the exponents. Now what if we have m to the 7th power over m cubed? Obviously, this is not anymore multiplication because this is a rational expression, so this suggests that the operation is division. To divide, we will expand the expressions on the numerator and denominator and cancel the common factors. What remains in the numerator are 4m's and nothing remains in the denominator, so the resulting expression, which is now the simplest form, is m to the fourth power. For r cubed over r squared, expanding it and cancelling the common factors, the resulting expression is r. But this time, I am again to introduce to you another method of simplifying these expressions without cancelling and without expanding. And how do we do it? We simply subtract the exponents. So that for the first example, we will have m raised to 7 minus 3, that is equal to m to the fourth power. And for the second example, we will have r raised to 3 minus 2, that is just r raised to 1 or simply r. So if I am to divide a raised to x and a raised to y, to do that, we will copy the base and then subtract the exponents. So you have a raised to x minus y. This is another law of exponent called the quotient of powers. And quotient of powers states that if you are to divide two powers having the same bases, copy the common base and subtract the exponents. Now let's have m to the 7th power over m to the 7th power. Notice that we are just dividing here exactly the same expression, so their expanded form are also the same. We cancel the common factors, and notice that nothing remains in the numerator and denominator. If that is the case, then the result is just 1. If I have r cubed over r cubed, expanding them, we will have r times r times r over r times r times r, and cancelling the common factors, nothing remains also in the numerator and denominator, so the result is 1. But if we apply quotient of powers, that means we will subtract the exponents. We will have m raised to 7 minus 7, that results to m raised to 0. And based from our previous answer, m raised to 0 will just be equal to 1. If I have r cubed over r cubed, that becomes r raised to 3 minus 3. And that is equal to r raised to 0. And based from our previous answer, that is just equal to 1. If that's the case, we can therefore say that if we are dividing exactly the same expressions, or if the exponent of any variable or any number is 0, then the result is just 1. This is another law of exponent called the zero exponent. And zero exponent states that any number raised to 0 is always equal to 1. Now let's take this expression, the quantity 3n raised to 4. Expanding it, we will have 4 3n's, and simplifying them, since there are 4 3's and 4 n's, we will have 3 to the 4th power, n to the 4th power. If I have also the quantity xy raised to 7, expanding them, we will have 7xy's, and so you see 7x's and also 7y's. Simplifying them, that becomes x to the 7th power, y to the 7th power. Given those examples, if I have the quantity ab raised to x, we can therefore simplify it as a raised to x, b raised to x, because we just raise the two numbers inside the parentheses to the power x. This law of exponent is called the power of a product. And power of a product states that if you are to raise a product to a power, raise the two numbers to the same power. Same is true if I have this expression, the cube of the quantity 5 over m. We expand it, so we see 3 5 over m's, and when we simplify, that becomes 5 cubed over m cubed. Also, if I have the quantity p over s raised to 6, we will see 6p over s's. And then simplifying them, we will have p raised to 6 over s raised to 6. So that mathematically now, we define it as if I have the quantity a over b raised to x, we can just simplify it as a raised to x over b raised to x. This is the last law of exponent that I want to share to you, and this is called the power of a quotient. And power of a quotient states that if you are to raise a quotient to a power, raise the two numbers, the numerator and denominator, to that same power. So let us summarize. I have given you 6 laws of exponents, namely product of powers, we add the exponents, power of a power, we multiply the exponents, quotient of powers, we subtract here the exponents, zero exponent, any number raised to 0 is always equal to 1. For power of a product and power of a quotient, we just raise the numbers inside the grouping symbol to that same power.